Hey guys, welcome back to my YouTube channel. So for today's video, I will do a packet tracer in chapter 3, investigating the TCP, IP, and OSI models in action. So this simulation activity is intended to provide a foundation for understanding the TCP, IP protocol suit the relation to the OSI model. Simulation mode also allows you to view the data content being sent across the network layer. So even though much of the information displayed will be discussed more detail later, this opportunity to explore the functionality the packet tracer able to visualize the encapsulation process. So first you have to download the PKA and then but I already download it, so we will open packet tracer. So here's the packet tracer. So first, the simulation, the so part 1, examine HTTP web traffic display element of the TCP/IP protocol suite. So the background is this simulation activity is intended to provide a foundation for the understanding the TCP/IP protocol suite and the relationship to the OSI model. So simulation mode allows you to view the data contents being sent across the network at each layer, and then as data moves through the network it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination piece. Each piece is assigned a specific name, protocol data unit PDU, and the associated with a specific layer of the TCP IP and OSI model. So packet simulation mode enables you to view each of the layer and associated PDU. The following steps lead the user through the process of requesting a web page from the web server by using the web browser application available on the client PC. So we have web server and web client. So even though much information displayed will be discussed in more detail later, this is an opportunity to explore the functionality of Packet Tracer and will visualize the encapsulation process. So, part 1, examine HTTP web traffic. In part 1 of this activity, you will use Packet Tracer simulation mode to generate web traffic and examine HTTP. So, step 1. In the lower right corner of Packet Tracer face are tabs to toggle between real-time and simulation mode. All, mm, Always starts in real-time mode in which networking protocols operate with realistic timings. However, a powerful feature of Packet Tracer allows the user to stop time by switching to simulation mode. In the simulation mode, packets are displayed as animated envelopes. Time is event driven and the user can step through network events. So click the simulation mode icon to switch the real-time mode in real-time mode to simulation mode. So you have to select simulation mode and then select HTTP from the event list filter. So we will choose we will select HTTP from the event list filter. So HTTP may already be the only visible event. So click edit filter. So here's the edit filter. So after you click the edit filter, it will show us this. So and, and then display available visible event. So this is the visible event, and toggle the show all none checkbox, and notice how the checkbox switches from unchecked to check or check to unchecked depending on the current state. So we have to click the show all none, and then here's the show all none. Then step B number 2 is click the show all none checkbox until all boxes are cleared, and then select HTTP. So we will click again the show all none for to unclear the display available event. So as you can see is unclear visible event, and we will select HTTP. So as you can see, event list filters visible events HTTP, and then click anywhere outside of the edit filter box to hide it. The visible event should be applied now. Only visible only display HTTP. As you can see, it is the event visible event HTTP. So let's continue. So step 2, generate web HTTP traffic. Currently, the simulation panel is empty. Um, there are 6 columns listed across the top of the event list within the simulation panel. As traffic is generated and step through event appear in the list, the info column is used to inspect the content of a particular event. So we have a note the web server and web client are displayed in the left pane, and the panels can be adjusted in size by hovering next to the scroll bar and dragging left or right when the double-headed arrows appear. So we will drag this left or right in the event list. So letter A, web client in the click web client in the far left pane. So we will click web client. So after that, click the desktop tab and click the web browser icon to open it. We will desktop and web browser. Click the web browser. After that, in URL field, enter the www.osi.local and click go. We will type the www.osi.local and then click go. You will minimize, and then because time in simulation mode is event driven, you must the capture forward button to display network event. So we will click simulation. So capture forward, click, and then the third D is click capture forward 4 times. One, and here we go. And there should be 4 events in event list. Look at the web. Did anything change? So it will change because the from the web client it has a message. So the contents of the HTTP packet. So click the first colored square box under the event list info column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. So we will drag right, and then first color square box under the event list. So here we go. And then the PDU information at device web client windows display. In this window, there are only 2 tabs, the OSI model and the outbound PDU details. So we have OSI model and the outbound PDU details. So because this is the start of the transmission. As more events are examined, there will be three tabs displayed, adding a tab for inbound video details. When an event in the last event in the stream or of traffic, only the OSI model in inbound video details tabs are displayed. So B. Ensure that the OSI model tab is selected under the out layer column. Ensure that the layer 7 box is highlighted. So we will ensure the OSI model is selected, and then OSI's ensure that the layer is highlighted. So as you can see, the layer 7 is highlighted, so it is correct. So let's move on to the next procedure or steps. So what is the text display next to the next what is the text display next to the layer 7 label? What information is stated on the number steps directly belong in the layer and out layer? So in layer is we have layer 4, 3, and 2 and 1. So in layer out is 6 and 5, and click next layer. Layer 4 should be highlighted. What is the DS port value? So we have to next layer, and then the DS port or the DST port is 80 for the layer 4, and then letter D is next layer. Click the next layer again, and then layer 3 should be highlighted. What is the destination IP value? So the destination IP value of layer 3 is 192.168.1.254, and then click next layer. What information then is layer? So what information is displayed at this layer? So we have the the next hop IP address is unicast. The ARP process look it up the ARP table. Number 2, the next hop IP address is in the ARP table. The ARP process set the frame destination MAC address to the one found in the table. The device encapsulate the PDU into the Ethernet frame. So this is the display at this layer. So F is click the outbound PDU detail tab. So we will click the outbound PDU detail tab. So after that, information listed under the PDU details is reflective of the layer within the TCP IP model. So here's the um, information. So note the information listed under the Ethernet 2 section provides the even more detailed information than is listed under layer 2 on the OSI model tab. And then the outbound PDU details provide more descriptive and detailed information. The values under the desk MAC and the SR MAC within the Ethernet 2 section of the PDU details appear on the OSI model tab under the layer 2 but are not identified as such as. So what is the common information listed in the IP section PDU? PDU are as compared information listed under the OSI model to which layer is associated. So so the desk so SR Mac is uh, so again, so click the next colored box to the event list info column. The only layer 1 is active, not grayed out. The device placing on the network. So we will drag this again, and then next colored square box. So as you can see, only one layer is highlighted. So only one layer is active, not grayed out. So So advance to the next HTTP info box within the event list. Click the colored box Click the colored square box. This window contains the both in-layer and out-layer. Notice the direction of the arrows are directly under the in-layer columns. The pointing upward indicated the direction information is traveling. Scroll through this layer, making note of the items previously viewed at the top of the columns, and the arrows point to the right. This denotes that the server is now sending the information to the client. So advanced. Then please click the in advanced determinant within the event list and click the colored square box. So as you can see, it has a arrow. So the windows, but you notice as you can see, it is point upward, indicating direction information traveling. Scroll from in this layer to the in layer to the out layer. So click the outbound PDU detail tab, scroll down to the HTTP section. So we will click the outbound. So we have a OSI model, inbound PDU details, and outbound PDU details. So we have to click outbound. So scroll down to the HTTP section. So HTTP response, HTTP connection close, content length 170. So click the last colored square box in the info corner. How many display with this event? We will click the last. So as you can see, how many times we display? Um, we have the elements of TCP/IP protocol suite. So in part 2 of this activity, you will use the packet tracer simulation mode to view and examine some of the other protocols comprising the TCP/IP suite. So step 1, view additional events. So close any OpenPD information window. So as you can see, we will close the all information window. And then in the event list filter, visible event section, click the show all. So here's the event list. So we will click that show all. So this extra entries play various roles within the TCP/IP suite. If the address resolution protocol ARP is listed, it searches MAC address DNS responsible for the converting meaning. For example, www.osi.local to an IP address. The additional TCP events are responsible for connecting, agreeing the communication parameters, and disconnecting the communication session between the devices. These protocols have been mentioned previously and will be further discussed as the course progresses. Currently, there are over 35 possible protocol event types available for capture within the packet. So, click the first DNS event at the info column, first DNS, and then explore the OSI model and PDU detail tab and note the encapsulation process. As you look at the OSI model tab within the layer 7 highlighted as description of what is occurring is listed between the in layer and out layer DNS. So in layer is DNS client send DNS query to the DNS server, like as you hear. And then this is the very useful information to help the understand what is scoring during communication process. And then click the outbound. So what information name in the DNS query section. So here's the DNS query section, and for the name is www.osi.local. So click the DNS info colored square in the event list which device is displayed. So DNS, we will DNS info. So the DNS display is um, web client, and then what is the value of in the what is the value listed next to the address in the DNS? So DNS. So find the HTTP first event in the list and click the colored square box. So we have to search the first HTTP, and then TCP event immediately following this. Highlight layer 4 in the OSM model number listed directly, and what is the information displayed in number item form. So here's the uh, layer 4 send segment information, the sequence number 1, the ACK number 1, and data length is 102. So let's move on. So TCP manage yes the connecting and disconnecting of the communication channel along with the responsibilities. This particular event showed that communication. So click the last TCP event. So here's the last TCP event, and then highlight layer 4, and then in the OSI model, examine the step listed directly below in the layer and outlier. What is the purpose of this event based on the information provided in the last item in the list should be in item 4. So here's the information in layer 4. So the device receives a TCP ACK segment of the connection to 192.168.1.1 on port 1025. Number 2. Receive segment information, the sequence number 104, the ACK number 273, and the data length is 20. Number 3. The TCP segment has expected peer sequence number, and number 4, and last, the device sets the connection and the state is to close. So it's already done. So thank you for watching, and I hope you enjoy my video, and I hope you gain a lot of knowledge, and thank you for watching.